Okay, this is our semester 1 post-test preview, and we're going to practice and get ready for our post-test tomorrow. Michael solved the following equation incorrectly, so please do not write "there is no error." Oh, literally, I've gotten that answer before. It does say that it has been done incorrectly. Okay, so tell what the error is and solve the problem correctly. All right, so we look at here and we go start looking at his work. Okay, he did not distribute correctly. Okay, he did not distribute the 1/2 to what? Yep. Okay, so if you wrote, I'm not saying this is the only way to write the error. You got to describe the error, though, in some form. You don't write that he did it wrong. That would not constitute what the error was, okay? All right, so then to show the correct work, I really don't need to rewrite the equation. I'll just show this step solved correctly. That would be 1/2 x plus 3 instead of what he had, which was 6. And then you would have subtracted 3 and gotten 15. And then you would have multiplied by 2 and get 30. Okay. So this is what you need to show the error. Okay. Number 2 says solve and graph the following inequality. Show your answer in interval notation. You should set this up into 2 separate equations. X minus 3 is less than or equal to 9 is the first one. The second one is x minus 3 is greater than or equal to -9. Flip the sign, change the sign. Never change what's in the absolute value. You do not change the sign in between there or anything. It stays x minus 3, x minus 3. All right, so then you add 3 to both sides and you get x is less than or equal to 12. The second inequality, you add 3 to both sides, you get x is greater than or equal to -6. Well, that means x is bigger than -6, but less than 12. So it's between -6 and 12. And it included those numbers, so we'd have bars underneath, because there was a bar underneath the inequality in the beginning. It said less than or equal to. The graph solution would be inclusive of -6 up to 12, inclusive of 12. And that would be the exact same thing basically for the interval, except you don't make any shading between. You put a comma. If I'm going it all too fast, let me know. Any questions about number 2? All right. Next one. Solve the following quadratic by using square roots. We would need to subtract 60 from both sides. That give us -48. Now, I had a lot of you on the quiz where this was last time. Take the square root right now. You can't do that. You need to isolate the x squared first. So we need to divide by 4 before taking the square root of both sides. If we divide by 4, we get -12. We then take the square root of both sides, and don't forget it's plus or minus the square root of -12. We then need to simplify the radical. So it's going to be plus or minus the square root of -4 times 3. You don't have to write all these steps if you get it. And that is an equal sign. Then you take the square root of -4, which is 2i. So this would be plus or minus 2i times the square root of 3. Okay. Number 4. Boy, these are nice and spread out. Those are only 3 problems on the first page. Using technology, find the zeros to 2 decimal places. So we grab a calculator. We type in, I forgot what it was. Thank you. X squared minus 3x minus 12. Okie dokie. Then we're going to hit graph. And then I see that those are not very nice zeros. They're decimals. So I'm going to hit second trace. Choice 2. And that first zero on the left is between -3 and -1. So I'm going to enter -3 for my left bound and -1 for my right bound. And hit enter. And then hit enter again. I land on the zero at -2.27. Okay, that's one of the zeros. Now I go back to the calculator to get the other one. Second trace. Choice 2 for 0. That one's between 1, 2, 3, 4, and 6. So I'm going to do 4 for my left bound, 6 for my right bound, and then guess. 5.27. Okay. Not really liking the way they wrote these, so it really should be 5.27 comma 0. I mean, that's technically it. Now, if you just put those answers on the blanks, that's fine. I usually prefer them written as points, though. Okay? What? No, it doesn't round to that, so you don't, that's not how you round. Okay, so let me explain rounding. 5.274, then there was a 9, right? When you round, you're going to it said to go to 2 decimal places, which is the hundredths, the tens, hundredths, thousands, 10,000. You look behind the place you're going to round to, and if it's 5 or larger, then you round up. If it's not 5 or larger, if it's under 5, then you do not, you drop off the rest of the decimal. But who told you to do that? That's what I'm trying to explain. Okay, let me explain it again. If you are going to round to the nearest thousandths, you would round this up because the number after the thousandth place is bigger than 5. It didn't say to round to the thousandths. It said to round to the hundredths. So you don't even care what's behind the 4 at all. You're only supposed to be looking at this number to round to there. So ignore that. Yes, really. But I promise I'm not lying to you. Okay. Promise. All right, these are correctly rounded to the place that we were supposed to go to. All right. So, hey, you know what? Why not? We had a golden moment for you. Hopefully that sunk in. Yes. It did just say X, so I wouldn't have marked that off, no. I prefer them as points, but if it says X equals, that's what we should have written, yeah. No, not, if I just had a blank there, then I expect you to write the point down. If it had X equals, though, you've got to write down the X value, right? Okay. All right, this says to subtract the G function and the f of X function. You have to do it in the right order. So X squared minus 2 minus parentheses 4x minus 3, and then you need to simplify that correctly. So that would be x squared minus 2 minus 4x plus 3, and that gives us x squared minus 4x plus 1. Number 6 says to do the f of g of 3. Now, let me try to get, since I have the time, I want to try to explain this in another way that maybe would help if you haven't been getting this. What are you supposed to do first on this? No. Then I don't mean that what would you need to do first to simplify this? Yeah, you always do the innermost parentheses, right? So you want to do the innermost parentheses here. Now, there's nothing to do inside the parentheses where the 3 is. But inside this parentheses, you're supposed to do the g of 3. What does that mean? Yeah, plug 3 into the g function. So do 3 squared minus 2, which is 9 minus 2, and that gives us 7. Okay, now you have just done this part. So now you're going to do the f of 7, which means put 7 into the f function. The f of 7 then will give you 4 times 7 minus 3, and that's 28 minus 3. So what's your final answer? That's a minus, by the way, 25. So I hope at least someone got help from that. Yes. What did you do? Oh, okay. So you did the f of g of x first. Okay. You can do that. I just think there'd probably be more possibilities of errors just because sometimes they get a little more complicated, especially if it's to do the g of f of x. Okay. And if it's said to do the g of f of 3, that might mess you up a little bit, but whatever. If you've got 25, it's not incorrect because you apparently plugged this in correctly. Okay? Consider the function f of x equals 3x plus 3. Find the inverse of f of x. Okay, so what we do first is remember that f of x is like y. And so we're going to switch x and y. The next step is to solve for y by subtracting 3. And then divide by 3. Now, f inverse of x is notation for the inverse function of f of x. If you're going to divide by 3, some people might leave it like that, but I tried to get you guys to simplify it, okay? So I said, how many x is that? 1/3 x minus 3 divided by 3 is 1. I wouldn't mark you wrong if this is what you had for your inverse, but your graph better be correct as well. So graph both the original function and the inverse on the coordinate plane. The original function has a y-intercept of 3. I'm going to do it in red. And a slope of 3. Up 1, 2, 3, right 1. Down 1, 2, 3, left 1. Okay, so I'm just getting on here as many points as I can, and I'm actually going to use my tool to make a nice line. Okay, so then I put arrows on it. All right, now I'm going to do the graph of the inverse of f of x. The inverse function has a y-intercept of -1 and a slope of 1/3, up 1, right 3. It should look like it's a reflection in the line y equals x, which you don't have to draw. Ooh, do too bad without that tool. All right, you don't have to draw in the line y equals x. But there is another way you could have gotten that graph correct, and that would be, just notice that we have some points on here, Nathan. Go ahead. This? Yeah, you can. No, I would leave it like that. I mean, if you left it like this, or if you had x minus 3 minus 1, that's not wrong. Okay, so no, I wouldn't mark off. The problem is I hope your graph's right. So if I look at the original, here's another way to get the graph though, guys. I have points already on the red graph of 0, 3. So if you actually had written down some of the points on this graph, like 0, 3, negative 1, 0, 2, 9. You can go and take those and flop them for the inverse by just reversing the x and the y, switching the x and the y. So you can go 3, 0, bingo. Wait, I wrote 9, 0. It should be 9, 2, excuse me, which is right there. And then 0, negative 1 is right there. Okay. So that's another way to get it graphed. All right, moving on. Number 8. This is a function because it's a parabola that passes the vertical line test. So yeah, it's a function. Its domain's negative infinity to infinity, and its range is from, is that negative 5? Okay, inclusive of negative 5 because the vertex is included on up to infinity. We're good? Would its inverse be a function? No, it would not, because this graph does not pass the horizontal line test. Okay, we didn't do too hot on this on the quiz that we had with this on it. Travis throws a water bottle upward. The height of the bottle t seconds is given by the following equation. He really threw that bottle hard because it went out at 82 feet per second. Complete the table to show the heights of the given times. All right, we can do this off the grapher, or we can plug in values for t. Okay, so I'm thinking you guys will probably go to the graphing calculator. Okay, so negative 16x squared. You have to replace the t's with x's, of course. Plus 82x. And then I forgot the height. Was it 4 feet? Plus 4. So that means his arm was at 4 feet when he whipped the bottle. Must have launched it from the side. Anyway, I don't really need the graph at all. I just need to go to the table and find out it was at 3, 4, and 5 seconds. 106, 76, 14. Okay, then it says find the average rate of change, or the slope, in the height from time of 3 seconds to 4 seconds. You remember that slope formula? Rate of change is y2 minus y1 over x2 minus x1. Okay, so these would be your y's and these would be your x's. Your time is the x. So I'm going to be doing it from 3 to 4 seconds. So I have to do 4 seconds for 76 minus 106 over 4 minus 3. And that's 30 over 1, which should have a label of 30 feet per second. The rate of change over the period of 1 second there is 30 feet per second. If you'd done it, the rate of change over 3 to 5 seconds, oh, and by the way, that was negative, right? It's coming down. Okay, if we did, I forgot to put my sign on there. If you did like from 3 to 5 seconds, you'd be doing 14 minus 106 over 5 minus 3, and you would have had to divide by 2. Okay. Any questions about that? Okay, 10, CJ, graphed the following absolute value function incorrectly. Don't tell me it's graphed correctly. It's not. All right, so this is the equation. F of x is the absolute value of x plus 3 minus 2. That format that we're supposed to know and have memorized over the semester is a times the absolute value of x minus h plus k. All right, you're supposed to already know that, where hk is the vertex. All right, this one, what's wrong with it? He's got the vertex at where? 3, negative 2. And it should be, I didn't also do the graph right at all. Do you see what's wrong also? What about the A value? Did he go up one, right one? Okay, and it's too narrow, so he's got two problems going on here. I don't even remember. I didn't talk about that one second hour. Wait, he has the wrong vertex? He has the wrong vertex and slope, right? Okay, so the vertex, it said to do it correctly. So what did he do wrong? So if you wrote the vertex should be -3, -2, that's where it should be. Left 3, down 2. And then the branch is a slope of 1, so it goes up 1, right 1, up 1, right 1 on the right side. Did I plotted that right, didn't I? Okay. And then that's the right branch. And the left branch is up 1, left 1. So he didn't have this thing shaped right even. He made it too narrow, as you know. So then Miss Heimer would have marked it wrong. Sorry, CJ. Some very large snowflakes outside. Did not know it was supposed to be snowing quite that much. I heard snow, but I didn't know it was, yeah, that's real snow. Holy cow. Okay, 11. We only have 5 more to go. Graph the polynomial following polynomial function, identify any zeros, show the end behavior. All right, so you probably would go ahead and go in your graphing calculator. Excuse me. Got a tickle in my throat. Go clear out what's in there, and then I forgot what it started with. It was x cubed, and then what? Okay. Plus 7x squared plus 4x minus 12. Okay, hit graph. And oh, how nice. We got some beautiful zeros here. It looks like 1, -2, and -6. Want to verify that? We hit second trace, choice 2, and then check them. They are -6, -2, and 1. You can go second table and see if those are points on there. 1, 0 is, and then you'd have to go back up a little bit. Oh, look, yep, -6, 0, -2, 0, and 1, 0. Okay, so plot those. And then, and those, see how it says zeros? That's where I mean don't just write numbers. -6, 0, -2, 0, and 1, 0. Now, I went and checked what the max was to try to graph this thing. I mean, I can see the end behavior is down on the left and up on the right. But in between, if I wanted to find out the relative maximum, I could tell the grapher to do it for me without even changing my window. I can tell it's between -6 and -2, so I put a left bound of -6 in and a right bound of -2. And then have it go find that relative max for me. It's at 20.7 high. Okay, so -4 point something, 20 point, it's up there. So I'm just going to sketch this because clearly we weren't meant to fit it on this graph. But anyway, did anybody check what the min is? Well, I know there's a -12 y-intercept, so at least it goes way down there and then comes back up. So f of x is pointing down towards -infinity as on the x is okay, say that right. F of x is going towards -infinity as x approaches -infinity, which means the left side. And then the graph is pointing up on the right side as x approaches infinity. Did he have reindeer horns on or something? Okay, factor the following quadratic. This factors to x, let's say, minus 16x plus 2. Good enough? Write the following polynomial as a product of two binomials. That means we need to factor it by grouping. Because there are 4 terms, try factor by grouping. I see an x squared in common. I bring it out. I'd have 2x plus 3 left. The second pair of numbers or terms, I factor out a 4. I get 2x plus 3. Oh, goody. Since these match, it was factorable by grouping. I factor out a 2x plus 3. And then what's left is butted up against there times x squared plus 4. And x squared plus 4 cannot be factored because it's a sum of perfect squares, not a difference. Yeah. But technically, you were factoring away the 2x plus 3. All right, Jenna was asked to show the complete factorization of the following polynomial. Jenna's factorization, 3x times x squared minus 16. Is this completely factored? No. If not, what is the complete factorization? 3x times x minus 4, x plus 4, or x plus 4, x minus 4. It doesn't matter what order. And the last one, anybody still need this? Use completing the square to rewrite the following quadratic equation into vertex form. Okay, so completing the square means you want this to be a perfect square trinomial. It's not at the moment, but there's that plus 18. If you're going to add something on the right-hand side, and you're going to complete the square on both, do everything on the right. If you add something, you must also subtract it. Okay, so I'm going to have a subtract blank. Then I figure this out as x minus 2 quantity squared. The sign should match. It's half of negative 4 that goes here. And then half of negative 4 squared would be the same as 2 squared. I just never write the negative sign because I don't want you to make a mistake on squaring a negative. Okay, so simplify this guy. So that's going to be plus 18 minus 4. So the answer is x minus 2 quantity squared plus 14. And then if you were asked to tell what the vertex is, it would be at 2, 14. It didn't say to do that, but the heck. Okay, this is the preview of what you're expecting tomorrow on the post-test. All good? I hope you feel comfy, and we'll be ready to do a good job tomorrow.